In September 1939, Britain declares war on Nazi Germany. The Royal Artillery rolls into position with a field gun that first saw service during the Boer War era. Meanwhile, the Wehrmacht storms across Poland with modern artillery designed in the 1930s. British gunners are preparing to fight with weapons whose basic design dates back to 1904. Military observers on both sides of the channel are asking the same question. How can Britain possibly compete with obsolete guns against a modern mechanized army? The 25-pounder field gun, Britain's primary artillery piece throughout the Second World War, wasn't actually a new weapon at all. It was a clever reimagining of the 18-pounder field gun, the workhorse of the Western Front that had fired millions of rounds between 1914 and 1918. By the time Neville Chamberlain announced Britain was at war, the Royal Artillery had approximately 1,000 of these converted guns ready for deployment. Defense analysts viewed this situation with considerable alarm. Here was the British Empire, supposedly a great military power, going to war with recycled artillery, whilst Germany fielded the LEFH 18 105mm howitzer, a purpose-built modern design. The British Army itself wasn't particularly confident either. Senior officers at the War Office knew they were sending men into battle with what appeared to be museum pieces on wheels. The Treasury had starved the military of proper funding throughout the 1920s and 1930s, leaving procurement officers with an impossible choice: spend years developing entirely new artillery systems, or modify existing weapons already sitting in storage depots across the country. They chose modification, a decision that seemed like desperate penny-pinching at the time. Yet this apparently obsolete gun would go on to become the most respected field artillery piece of the entire war. British gunners would fire it in anger from the deserts of North Africa to the forests of Burma, from the beaches of Normandy to the bridges over the Rhine. Commonwealth forces from Australia, New Zealand, Canada, South Africa, and India would come to trust it implicitly. By 1945, even American artillery officers, whose own 105mm howitzer was excellent, admitted grudging respect for the 25-pounder's accuracy. The gun's reputation rested on one critical advantage. It could place shells exactly where forward observers wanted them, consistently, even under the most challenging battlefield conditions. Whilst German and American artillery relied on volume of fire, saturating an area with shells, the 25-pounder could strike specific targets with what gunners called surgical precision. A battery of 8 25-pounders could knock out a machine gun position at 12,000 yards without wasting ammunition on the surrounding countryside. This accuracy wasn't an accident of good fortune. It emerged from a combination of innovative engineering, hard-won experience from the Great War, and the peculiar constraints of Britain's interwar budget crisis. The very fact that designers were forced to work with existing gun tubes meant they had to be exceptionally clever about every other component. They couldn't simply design a bigger gun with more propellant. They had to extract maximum performance from a barrel that had already served in the trenches of the Somme. What the military establishment initially viewed as a liability, reusing old guns, turned out to be Britain's secret weapon. The 25-pounder would serve in frontline combat for nearly 50 years, long after the modern German guns had been scrapped. Some would still be firing in anger during the Gulf War of 1991, not bad for a gun that started life when King Edward VII was on the throne and the airplane had barely been invented. The story properly begins in 1904, when the Royal Arsenal at Woolwich completed trials on a revolutionary new field gun design. The Ordnance QF 18-pounder wasn't the first British artillery piece, obviously, but it represented a fundamental shift in how guns were conceived. QF stood for quick firing, and that designation mattered enormously. Previous field guns had required the entire barrel to recoil backwards after each shot, forcing crews to relay the gun before firing again. The 18-pounder featured a hydro-spring recoil system that absorbed the shock, keeping the gun carriage stationary whilst only the barrel moved. Crews could fire up to 20 rounds per minute when pressed, a rate that seemed almost science fiction to artillery officers raised on Victorian-era weapons. The gun fired an 18.5-pound high-explosive shell, hence the name, to a maximum range of about 6,500 yards. By modern standards, that's unimpressive, barely 4 miles. But in 1904, it made the 18-pounder one of the most capable field guns in any army's inventory. The Royal Field Artillery began receiving the weapons in 1906, and by the outbreak of the Great War in August 1914, Britain had approximately 200 of them ready for action. They would form the backbone of British artillery throughout the conflict. On the Western Front, the 18-pounder proved itself under the most horrific conditions imaginable. At the First Battle of Ypres in October 1914, British gunners fired the weapons continuously for days, barrels glowing red-hot as they held back German advances. During the Battle of the Somme in 1916, 18-pounders participated in the preliminary bombardment that expended over 1.5 million shells in 7 days. The sound could be heard in London 140 miles away. The guns weren't just firing at trenches. They were cutting wire, suppressing machine gun positions, and providing close support for infantry attacks that often stalled within yards of the starting line. Gunners learned brutal lessons about accuracy under fire. In the flat, churned landscape of Flanders, even a 50-yard error could mean shells landing on your own troops rather than the enemy. Forward observers developed increasingly sophisticated methods for correcting fire, using telephone lines and later wireless sets to adjust aim. The concept of the creeping barrage, a moving wall of shell fire that advanced just ahead of attacking infantry, demanded precision that earlier generations of artillerymen had never imagined necessary. By 1918, the Royal Artillery had accumulated more practical firing experience than any artillery force in history. Officers had compiled volumes of data on shell trajectories, propellant behavior in different temperatures, barrel wear patterns, and 1,000 other variables that affected accuracy. These weren't theoretical calculations from a laboratory. This was knowledge purchased with 4 years of industrial-scale warfare. Approximately 99.5 million 18-pounder shells had been manufactured during the war, and a substantial portion of them had been fired in anger. When the armistice came in November 1918, Britain possessed thousands of 18-pounders in varying states of wear. Some had fired tens of thousands of rounds and needed complete barrel replacements. Others were nearly new, having been manufactured late in the war. All of them were stored away as the army demobilized, and Britain tried to forget the nightmare of the trenches. Those guns sat in depots throughout the 1920s, carefully preserved but increasingly obsolete as other nations developed new artillery designs. Yet, the institutional knowledge remained. The Royal Artillery remembered exactly what made a field gun effective in modern warfare. They understood that accuracy mattered more than raw power, that mobility affected survival, that crews needed to get into place and fire quickly before enemy counter-battery fire found them when the time came to design a new weapon for the next war. All those lessons from the Western Front would be baked into the specifications. The 18-pounder's legacy was just beginning. The 1920s were unkind to the British military. The Great War had bankrupted the nation, killing nearly 1 million men and consuming resources on a scale that Victorian Britain could never have imagined. The Treasury, desperate to restore fiscal sanity, slashed defense spending with enthusiasm that bordered on vindictiveness. The 10-year rule, adopted in 1919 and repeatedly renewed throughout the decade, assumed Britain would face no major war for at least 10 years. This convenient fiction allowed politicians to justify keeping the army on a starvation budget, whilst the Royal Navy and the fledgling Royal Air Force competed for scraps. For the Royal Artillery, the implications were stark. Germany, despite losing the war, was already thinking about next-generation weapons. France was developing new artillery designs. Even Poland and Czechoslovakia were investing in modern guns. Britain, meanwhile, couldn't afford to replace the thousands of 18-pounders sitting in storage. The weapons were wearing out. Barrel rifling deteriorated over time, even without firing. But designing an entirely new field gun from scratch would cost millions of pounds. The Treasury simply wouldn't authorize artillery. Officers at Woolwich faced a problem that combined tactical and financial impossibilities. The 18-pounder's maximum range of 9,300 yards, improved from its original 6,500 during the war, was becoming inadequate. Modern armies were more mobile, fighting at greater distances. The gun's caliber, 3.3 inches, delivered insufficient explosive power compared to the heavier shells other nations were adopting. But starting fresh meant designing new barrels, new carriages, new sights, new ammunition, new training manuals, new everything. The cost would be astronomical, and the Treasury had made its position painfully clear. There was no money. So the artillery specialist proposed something radical. What if they didn't design a completely new gun? What if they took those thousands of stored 18-pounder barrels and modified them? The idea seemed absurd at first. You can't simply bore out a gun barrel to a larger caliber and expect it to work properly. Except perhaps you could. Engineers calculated that the 18-pounder barrel could be bored out from 3.3 inches to 3.45 inches, creating what they called the 25-pounder, based on the new shell weight. The steel walls would be thinner, but still within safe tolerances for the pressures involved. The proposal gained traction in 1933, when the international situation began deteriorating. Hitler had come to power in Germany, and whilst most British politicians preferred not to think about the implications, military planners couldn't afford such luxury. The director of artillery submitted a formal recommendation: convert existing 18-pounders rather than wait years for a completely new design. It was pragmatic, it was affordable, and critically, it could be done quickly using existing manufacturing infrastructure. Treasury officials loved the idea because it was cheap. Artillery officers accepted it because it was achievable. The decision was made in 1935 to proceed with development, and by 1936, prototypes were undergoing trials. The new 25-pounder wouldn't just be a bored-out 18-pounder, though. Engineers designed a completely new carriage, the Mark II, that incorporated modern features like split trails for greater traverse and a circular firing platform that allowed all-round fire without moving the entire gun. The old 18-pounder barrel would sit atop this modern mounting, creating a hybrid weapon that combined proven technology with contemporary innovations. This compromise looked like second-best thinking, the kind of make-do solution that Britain would later become infamous for during the war. Critics pointed to German artillery development, where designers were creating purpose-built modern weapons without constraints of old barrels and limited budgets. But the British approach had one underappreciated advantage. It forced designers to be extraordinarily clever about everything except the barrel itself. They couldn't compensate for limitations with brute force. They had to engineer precision into every component. The engineering challenge was more complex than simply drilling out old barrels. Each 18-pounder barrel had to be inspected, measured, and assessed for wear patterns. Some had fired so many rounds that the rifling was nearly smooth. These went to the scrap heap. Others showed acceptable wear and could be machined to the new 3.45-inch caliber. The boring process required extreme precision. Even a deviation of a few thousandths of an inch would affect accuracy and could cause dangerous pressure variations when firing. The new shell was a compromise in itself. At 25 pounds, it sat between the old 18-pounder and the heavier shells fired by howitzers. British ordnance designers settled on an 87.6 millimeter diameter, which gave them flexibility in propellant loads. The shell could be fired with different charge configurations, from charge 1 for close-range work at lower velocities to charge 3 for maximum range. This variable charge system, adapted from howitzer practice, gave the 25-pounder unusual versatility. A single gun could provide both the flat trajectory, direct fire of a traditional field gun, and the high-angle plunging fire of a howitzer. The carriage design represented the most significant innovation. The Mark II carriage featured split trails that opened in a V-shape, creating a stable firing platform. Between the trails, engineers mounted a circular base plate that the gun could traverse through 360 degrees. This meant crews could engage targets in any direction without manhandling the entire weapon around, a feature that would prove invaluable in the fluid mechanized warfare of the Second World War. German and American guns of the period typically offered 45 to 60 degrees of traverse. The 25-pounder could spin completely round if needed. The muzzle brake was another critical addition. This device, fitted to the end of the barrel, redirected propellant gases backwards and sideways, countering some of the recoil force. It allowed the lighter 25-pounder carriage to handle the increased pressures of the larger shell without the entire weapon bucking violently backwards. Muzzle brakes weren't new technology. Various armies had experimented with them for decades, but the British design was particularly effective, reducing felt recoil by approximately 30%. Sighting systems received equal attention. The Mark II sight incorporated improvements based on 2 decades of artillery experience. It featured graduated scales for range and deflection, built-in spirit levels for ensuring the gun was level before firing, and adjustments for wind drift, air temperature, and propellant temperature. These variables mattered enormously at longer ranges. A 25-pounder firing at maximum range, 13,400 yards with charge 3, would see its shells affected by even modest crosswinds. The sight compensated for this, allowing gunners to dial in corrections based on forward observer reports. Assembly began in 1938 at Royal Ordnance factories across Britain. The conversion process was methodical. Strip the 18-pounder barrel from its old carriage, transport it to the boring facility, machine it to the new caliber, rifle it to the updated pattern, proof test it by firing high-pressure test rounds, and then mount it on the new Mark II carriage. Each converted gun underwent final trials before acceptance into service. Production ramped up as war became inevitable, but by September 1939, only about 1,025-pounders were available. The Army needed thousands more. Manufacturing accelerated dramatically once war began. Royal Ordnance Factory Nottingham became the primary production site, eventually producing several thousand carriages. Barrel boring was distributed across multiple facilities to spread risk from German bombing. By 1940, production reached approximately 100 guns per month. By 1942, that figure had tripled. The gun that began as a budget-saving compromise was now being manufactured at industrial scale, each one incorporating those carefully engineered features that would make it the most accurate field gun in any army's inventory. North Africa became the 25-pounder's proving ground. When British and Commonwealth forces deployed to Egypt in 1940 to defend against Italian advances from Libya, the desert offered conditions utterly unlike the Western Front. No trees, no buildings, no convenient terrain features to hide behind, just vast expanses of sand, rock, and scorching heat that could reach 50 degrees Celsius in summer. Artillery had nowhere to hide, and neither did the enemy. Battles became contests of maneuver and accurate fire, exactly the environment where the 25-pounder's advantages would shine. The Western Desert Force, later renamed the 8th Army, initially faced Italian artillery that outnumbered them significantly. During Operation Compass in December 1940, British gunners discovered they could engage Italian positions from ranges where return fire was ineffective. The 25-pounder's maximum range of 13,400 yards gave British forces a crucial standoff advantage. At the Battle of Sidi Barrani, Royal artillery batteries systematically destroyed Italian gun positions, firing from positions the Italians couldn't reach. The accuracy was remarkable. Observers reported 25-pounders hitting target zones consistently within 50 yards at ranges exceeding 10,000 yards. Then Rommel arrived in February 1941 with the Afrika Korps, and everything changed. German artillery doctrine emphasized aggressive counter-battery fire, locate enemy guns, and destroy them quickly. Rommel's gunners were professional, experienced, and equipped with capable weapons like the 105mm LFH-18. The Desert War became a deadly chess match where artillery batteries had to fire, then relocate before German spotters could direct counter-battery fire onto their positions. The 25-pounder's all-round traverse proved invaluable here. Crews could engage in place, fire in multiple directions as targets presented themselves, then limber up and move within minutes. At the Siege of Tobruk, beginning in April 1941, Australian and British gunners used 25-pounders in both defensive and counter-battery roles. The garrison held approximately 72 25-pounders, and they fired constantly throughout the 240-day siege. German forces tried repeatedly to break through the perimeter, and each time accurately placed 25-pounder fire broke up the attacks. Rommel himself noted in his diary the effectiveness of British artillery, commenting that it was impossible to concentrate forces for an attack without being subjected to immediate and accurate shell fire. The gun's accuracy stemmed partly from its sophisticated fire control system. British artillery operated with a centralized command structure, where forward observation officers, often positioned with infantry units, could call down fire from multiple batteries simultaneously. The 25-pounder's calibrated sights and variable charge system meant that corrections could be applied quickly. If an observer reported, add 200, write 50, gunners could dial in those adjustments and fire again within seconds. German artillery, whilst effective, typically operated more independently with less coordination between batteries. Alamein in October 1942 showcased the 25-pounder at the height of its effectiveness. Montgomery's 8th Army assembled 908 25-pounders for the offensive, the largest concentration of British artillery since 1918. The opening barrage on October 23 involved these guns firing over 500,000 rounds in the first 24 hours. But this wasn't indiscriminate shelling. Fire was carefully planned and coordinated. Specific German and Italian positions were targeted with what observers called uncanny precision. One German officer captured after the battle reported that British artillery knew exactly where every gun, every command post, every concentration of troops was located. The desert campaigns established the 25-pounder's reputation decisively. By the time the Africa Corps surrendered in Tunisia in May 1943, British and Commonwealth gunners had complete confidence in their weapon. They'd proven it could outshoot equivalent German guns in accuracy, match them in range, and exceed them in versatility. The gun that critics had dismissed as a makeshift conversion had become the standard against which other field artillery was measured. The 25-pounder's legendary accuracy wasn't magic. It was physics and engineering working in harmony. Understanding why this gun could consistently place shells within tight target zones requires examining the mechanical systems that separated it from contemporary designs. Every component, from the carriage to the ammunition, contributed to a weapon system that treated precision as the primary objective rather than an afterthought. Start with the split-trail carriage, a seemingly simple innovation with profound effects. When the trails opened into their V configuration, they created a wide, stable base that resisted lateral movement during firing. The recoil forces, even with the muzzle brake absorbing some energy, were substantial, potentially shifting the entire gun sideways. German guns with box trails or single trails had narrower footprints and were more prone to this lateral displacement. The 25-pounder's wide stance meant it returned to battery, the firing position more consistently after each shot. Consistency is the foundation of accuracy. The circular firing platform amplified this advantage. Bolted between the trails, this steel plate allowed the gun to traverse through 360 degrees without the crew having to reposition the trails themselves. More importantly, it provided a level, stable surface that didn't change characteristics between shots. Fire into soft sand or mud with a conventional carriage, and each shot would settle the gun slightly differently, changing the geometry and thus the point of impact. The 25-pounder's platform minimized these variations. Crews could fire dozens of rounds and maintain point-of-aim accuracy. The sighting system incorporated lessons from millions of rounds fired during the Great War. The number 11 dial sight, standard on the 25-pounder, featured extremely fine graduations for both elevation and traverse. Elevation could be set to within 1/4 of a degree, traverse to similar precision. For context, at 10,000-yard range, a 1-degree error in elevation translates to approximately 175 yards of deviation in range. The 25-pounder's sights allowed adjustments far finer than this. Gunners could make tiny corrections based on observer feedback, walking shells onto target with minimal ammunition expenditure. Ballistic consistency mattered enormously. The 25-pounder fired a streamlined shell with excellent aerodynamic properties for its era. The shell's driving band, a copper ring that engaged the rifling, was precisely machined to ensure consistent spin rates. Spin stabilizes the shell in flight, preventing tumbling and reducing dispersion. British quality control on ammunition production was rigorous. Shells from the same production lot would have nearly identical weight, dimensions, and center of gravity characteristics. This uniformity meant that when a gunner set a specific elevation and charge, the shell would follow a predictable trajectory every single time. The variable charge system added another layer of precision. Rather than using fixed ammunition where the propellant charge was predetermined, the 25-pounder used separate loading ammunition. The shell was loaded, then the cartridge case containing the propellant charge was inserted behind it. Charges came in 3 increments: Charge 1, the smallest, Charge 2, and Charge 3 maximum range. Additionally, Charge Super was introduced later for extended range. This system allowed gunners to select the optimal charge for the target distance. Using a lower charge for shorter ranges meant the shell followed a flatter trajectory, spending less time in the air where wind could affect it. The result was tighter shot grouping at all ranges. Temperature compensation tables were another critical element. Propellant burns at different rates depending on its temperature. Cold charges produce lower pressures and shorter ranges than hot ones. British gunners used elaborate range tables that included corrections for propellant temperature, air temperature, barrel wear, and even the rotation of the Earth for long-range shoots. These weren't guesswork. They were based on exhaustive testing and mathematical modeling. Apply the corrections properly, and the 25-pounder would drop shells consistently within a 50-yard circle at maximum range. The invasion of Normandy on June 6, 1944, brought the 25-pounder back to European soil for the first time since Dunkirk. Operation Overlord involved landing approximately 425-pounders on D-Day itself, with hundreds more following in subsequent waves. The gun faced a completely different challenge than North Africa. Close terrain, hedgerows, villages, forests, and an enemy dug into prepared defensive positions. The open desert had favored long-range duels. Normandy demanded flexibility and rapid response to infantry requests for fire support. The bocage country of Normandy, those infamous hedgerows that turned every field into a natural fortress, created nightmare conditions for attackers. German machine gun positions, anti-tank guns, and mortar teams could hide behind earth banks topped with dense vegetation, invisible until they opened fire. Infantry couldn't advance without suppressing these positions, but locating them precisely was difficult. The 25-pounder proved ideal for this work. Forward observation officers accompanied infantry units, and when a German position revealed itself, the FOU could call down fire within minutes. The gun's accuracy meant shells could land within yards of British troops without endangering them. Operation Goodwood in July 1944 demonstrated coordinated artillery, fire on a scale not seen since 1918. Montgomery's attempt to break out from the Caen bridgehead involved 7 25-pounders, firing a preliminary bombardment onto German positions. The barrage lasted 3 hours and expended over 200,000 shells. Unlike the indiscriminate area bombardments of the Great War, this was targeted fire based on aerial reconnaissance and intelligence reports. Specific German strongpoints, headquarters, and artillery positions were engaged. Post-battle assessments showed the bombardment had been devastatingly effective. Entire German units were rendered combat ineffective before British tanks even began their advance. The adaptability of the 25-pounder became increasingly apparent as the campaign progressed. During street fighting in Caen, gunners fired at extremely short ranges, sometimes under 2,000 yards, using Charge 1 to drop shells precisely onto German-held buildings. In the breakout from Falaise in August, the same guns engaged retreating German columns at maximum range. The weapon's versatility meant artillery batteries could support operations across the entire tactical spectrum without needing specialized guns for different missions. River crossings tested artillery coordination to its limits. At the Rhine crossing in March 1945, Operation Plunder, British artillery laid down one of the most complex fire plans of the war. Over 3,000 guns participated, including more than 1,000 25-pounders. The barrage involved timed concentrations on specific targets, smoke screens to blind German observers, and creeping barrages to protect advancing infantry. The 25-pounder's reliable accuracy was essential. Shells had to land exactly where planned, or the entire synchronization would collapse. The operation succeeded, partly because British gunners could place fire precisely when and where commanders needed it. German artillerymen, when captured, frequently commented on British artillery effectiveness. Interrogation reports from prisoners taken after the Rhine crossing reveal consistent themes: the speed with which British guns responded to calls for fire, the accuracy of that fire, and the difficulty of conducting counter-battery operations against batteries that moved frequently. One German artillery officer noted that British guns seemed to know exactly where we were at all times, a tribute to the integrated fire control system that linked observers, command posts, and gun batteries into a cohesive network. By the time German forces surrendered in May 1945, the 25-pounder had fired millions of rounds across France, Belgium, the Netherlands, and Germany. It had supported every major British and Canadian operation from Normandy to the Baltic. Montgomery, never generous with praise for equipment, described the 25-pounder as the finest field gun of the war. Coming from a commander who'd fought across 2 world wars, that assessment carried weight. The gun that had seemed obsolete in 1939 had proven itself the most capable field artillery piece in the European theater. Ask any Royal Artillery veteran who served the 25-pounder, and you'll hear the same themes repeated: reliability, accuracy, and a curious affection for a weapon that never let them down. Gunner accounts provide insights that technical specifications cannot capture. The human experience of operating this weapon under the most extreme conditions imaginable. These weren't engineers or theoreticians. They were men whose lives depended on the gun functioning perfectly when it mattered most. Sergeant William Ross, who served with the 2nd Regiment Royal Horse Artillery in North Africa, recalled the confidence the weapon inspired. You knew exactly where your shells were going. The Jerry guns could throw more metal, heavier shells, longer ranges sometimes, but we could hit what we aimed at. First time, every time. That's what kept us alive. This sentiment appears repeatedly in veteran testimonies, the psychological advantage of trusting your weapon completely. German gunners might fire dozens of ranging shots to find their target. British crews expected to hit with their 2nd or 3rd round after initial ranging. The physical demands of operating the gun were substantial. A 25-pounder in action required a crew of 6 men working in perfect coordination. The gun commander controlled the engagement, translating fire orders into specific settings. The layer operated the sights, adjusting elevation and traverse. 2 loaders handled ammunition, one inserting the shell, the other ramming it home and loading the charge. The breech operator closed and opened the breech mechanism after each shot. Finally, the number 5 pulled the lanyard that struck the firing pin. In a well-drilled crew, the entire sequence from receiving fire orders to the first round leaving the barrel took under 30 seconds. Bombardier James Mallister, who fought through Normandy and into Germany, described the intensity of sustained firing. Your hands would be raw, ears ringing even with plugs, eyes stinging from propellant smoke. The gun would be so hot you couldn't touch the barrel. We'd fire for hours, sometimes hundreds of rounds, and your whole body would be shaking from the concussion. But the gun never quit, never jammed, never failed. You just keep feeding it shells, and it kept sending them downrange exactly where they needed to go. Maintenance routines were drilled into every crew. After sustained firing, barrels had to be cleaned to remove propellant residue that could affect accuracy. The recoil system required regular inspection: hydraulic fluid levels, seal integrity, spring tension. The breech mechanism needed cleaning and lubrication. Sights had to be checked for zero and adjusted if necessary. These weren't optional tasks. They were the difference between a gun that performed flawlessly and one that might fail at the critical moment. British gun crews took immense pride in their weapon maintenance, often working through the night to ensure their gun was ready for action at dawn. The all-round traverse feature earned particular praise from crews who'd experienced German counter-battery fire. Gunner Thomas Bradshaw, serving in Italy, explained, "Jerry was good at spotting our muzzle flashes and dropping mortars on us quick. With the 25-pounder, we could shift fire to a completely different direction without moving the whole gun. Saved our necks more than once. You'd be firing north, Jerry's shells start landing. You'd traverse to fire east and relocate. The old 18-pounders couldn't do that. You'd have to manhandle the whole thing around." Perhaps most revealing are the accounts of gunners who later served with other nations' artillery. Lieutenant David Morton, who liaised with American artillery units in 1944, noted, "The Yanks had a fine gun in their 105mm howitzer, no question. But they were surprised at how few rounds we needed to neutralize a target. They were taught to saturate an area. We were taught to hit the target. Different philosophies entirely. They respected what the 25-pounder could do, even if they wouldn't admit it officially. Victory in Europe didn't retire the 25-pounder. It began the gun's second career. Within months of Germany's surrender, British and Commonwealth forces were redeploying to conflicts across the globe, and the 25-pounder went with them. The weapon that had proven itself in European and North African warfare would spend the next 5 decades in continuous service, firing in anger on every inhabited continent except South America. Korea provided the gun's next major test. When North Korean forces invaded South Korea in June 1950, British Commonwealth forces deployed as part of the United Nations response. The 25-pounder faced conditions unlike anything it had experienced before. Korean winters where temperatures dropped to -30 degrees Celsius, mountainous terrain that limited mobility, and an enemy equipped with Soviet artillery doctrine and weapons. The cold presented immediate challenges. Hydraulic fluid in recoil systems thickened, propellant charges burned inconsistently in frozen conditions, and crews struggled to operate guns with frost-numbed hands. Yet the weapon adapted. Special cold-weather lubricants were developed for the recoil system. Propellant charges were stored in heated bunkers and only brought forward immediately before use. Range tables were recalculated for the extreme temperatures. At the Battle of the Imjin River in April 1951, British 25-pounders of the 45th Field Regiment provided crucial fire support to the Gloucester's regiment, which was being overrun by Chinese forces. The guns fired continuously for 3 days, expending over 10,000 rounds and breaking up repeated Chinese attacks. The accuracy proved essential. British positions were so close to Chinese assault waves that shells had to land within 100 yards of friendly troops. The Malayan Emergency, running from 1948 to 1960, presented entirely different challenges. Fighting communist insurgents in dense jungle required artillery to support infantry patrols in terrain where visibility extended barely 20 yards. The 25-pounder operated in fire bases cut from the jungle, providing on-call fire support to patrols that might suddenly contact enemy positions. The gun's rapid deployment capability was crucial. Crews could go into action, fire a fire mission, and relocate within 15 minutes, essential in an environment where insurgents would attack isolated positions. Suez in 1956 saw 25-pounders supporting British and French forces during the ill-fated attempt to seize the Suez Canal. During the parachute assault on Port Said, 5-pounders were airdropped in specially designed containers, then assembled and firing within hours of landing. This capability for rapid deployment had been developed during the war, but rarely demonstrated so dramatically. The guns provided fire support during the brief combat operations. Though the political disaster of Suez overshadowed any military achievements, India and Pakistan both operated 25-pounders, inherited from their time as British colonies, and used them against each other in the wars of 1965 and 1971. Pakistani gunners used 25-pounders during the Battle of Asal-Uttar in 1965, whilst Indian forces employed them throughout the 1971 war that resulted in Bangladesh's independence. Israeli forces captured 25-pounders from Arab armies and used them during the early Arab-Israeli conflicts. The gun's presence on both sides of various conflicts testified to its ubiquity across Commonwealth and former Commonwealth nations. The gun saw its last major conflict during the Falklands War in 1982. British forces landed 105mm light guns as their primary artillery, but several 25-pounders were deployed in supporting roles. At 37 years after the Second World War ended, the weapon was still considered reliable enough for combat operations. New Zealand didn't retire its last 25-pounders until 1989. The Indian Army operated them into the 1990s. Some sources claim a handful were still in service, with minor nations into the early 2000s, making the 25-pounder one of the longest-serving artillery pieces in history. Production totals tell the story of the gun's success. Approximately 12,000 25-pounders were manufactured between 1939 and 1945. They served with Britain, Canada, Australia, New Zealand, South Africa, India, and dozens of other nations. Some were destroyed in combat, some were scrapped after the war, but many remained in service for half a century after their first shots were fired. The 25-pounder's longevity poses a question that military historians still debate. How did a gun based on 1904 technology, converted from obsolete weapons as a budget-saving measure, outperform and outlast purpose-built modern artillery from wealthier nations? The answer reveals uncomfortable truths about military procurement and the difference between theoretical superiority and practical effectiveness. Consider the German Lefche 18, a 105mm howitzer designed from scratch in the 1930s, specifically for modern warfare. On paper, it was superior, heavier shell, comparable range, modern design philosophy. Yet it never achieved the reputation for accuracy that the 25-pounder earned. The German weapon was heavier, less mobile, and lacked the all-round traverse that made the 25-pounder so adaptable. German artillery doctrine emphasized mass fires rather than precision, which worked brilliantly when Germany had ammunition superiority, but became a liability when supplies tightened. The 25-pounder's philosophy, hit the target with minimal ammunition expenditure, proved more sustainable in a long war. The American 105mm M2A1 howitzer was an excellent weapon that served the U.S. Army superbly throughout the war and beyond. It was reliable, powerful, and produced in enormous quantities. Yet even American gunners acknowledged the 25-pounder's superior accuracy. The difference lay in design priorities. American artillery was designed for mass production and overwhelming firepower, accepting slightly lower precision as an acceptable trade-off. The 25-pounder prioritized accuracy above all else, accepting a lighter shell as the cost. Both philosophies worked, but in different ways. What the British conversion process forced was ruthless efficiency in every component except the barrel. Designers couldn't rely on a larger gun or more propellant to compensate for limitations. They had to extract maximum performance from what they had. This constraint produced innovations: the circular firing platform, the sophisticated sighting system, the variable charge ammunition, that wouldn't have seemed necessary on a clean sheet design. Sometimes limitations breed creativity in ways that unlimited resources cannot. The institutional knowledge embedded in the 25-pounder design represented 2 decades of artillery experience distilled into engineering. Every feature reflected lessons learned. The split trails addressed stability problems observed in the Great War. The muzzle brake compensated for the lighter carriage. The sights incorporated corrections that gunners had calculated manually in previous conflicts. The weapon embodied corporate memory in a way that brand new designs, created by engineers without combat experience, could not match. Post-war analysis by various militaries consistently rated the 25-pounder as the most accurate field gun of the Second World War. British tests in the 1950s compared it against more modern designs and found it still competitive in precision, if not in range or shell weight. The gun's accuracy stemmed from the accumulation of small advantages: stable platform, excellent sights, consistent ammunition, well-trained crews, that multiplied into a significant overall edge. No single feature made the gun exceptional. The integration of all features did. The weapon's longevity speaks to robustness and adaptability. Artillery pieces from the 1940s should have been obsolete by the 1970s, replaced by weapons with longer ranges, guided munitions, and improved propellants. Yet 25-pounders remained in service because they worked reliably under conditions that would defeat more complex weapons. Simplicity, when combined with precision engineering, creates durability that sophistication often cannot match. The gun had fewer failure points, was easier to maintain in field conditions, and could be operated by crews with less extensive training than more complex systems required. There's a broader lesson here about military procurement. The 25-pounder succeeded because it was designed to solve a specific problem, provide accurate field artillery fire, rather than to meet an abstract requirement for modernity. It wasn't the newest, the biggest, or the most technologically advanced. It was simply the most effective at its intended purpose. Defense establishments often forget this principle, pursuing cutting-edge technology over proven effectiveness, confusing complexity with capability. The obsolete gun that wasn't obsolete at all. Britain's supposed make-do solution, born from budget constraints and old barrels, became the benchmark against which field artillery was measured. It proved that clever engineering, institutional knowledge, and clear design priorities could triumph over raw technological advancement. The 25-pounder didn't just win the war, it defined what a field gun should be for the next half-century.